learners, and welcome to a revision on straight line functions. Before we begin, I think it would be a good idea to have a piece of paper and a pen in front of you, and I think it's a very good idea to push pause whenever something is said that you want to write down what's been said and write down something that you've learned that you might not have known before, and then to carry on watching the video. Right, let's begin with the straight line. A straight line is a graph which has a standard equation that is y is equal to something times x, which we call m, plus a constant, which we call c. The important thing that makes a straight line is that it must have in its equation a relationship between x and y, not x squared, not 1 over x, but between just plain x and y. Now, when you rearrange an equation so that it's in the form of its standard form of y is equal to mx plus c, you can then tell a lot about this particular function. The first thing that we can tell is that this m in the equation we know stands for the gradient of the graph, which is basically the slope of the graph, how steep or how shallow the graph is, whether it slants up or down. We should always remember that if a graph slants upwards, it would have a positive gradient, and if a graph slants downwards, it would have a negative gradient. We should also remember that there's a very easy way to find gradient. Gradient is the change in y divided by the change in x. That delta sign that I'm using, the triangle, is the Greek symbol for delta, but it means change in a particular coordinate. Now this formula is on your formula sheet, and it's written as gradient is equal to y2 minus y1 over x2 minus x1. So it's always very easy to calculate from a graph. The other basic thing in our equation, which is very useful, is that the c, the constant at the end of an equation in a straight line, stands to represent the y-intercept. So your y-intercept of any straight line can be seen from the standard form. X is 0 and the y-intercept is c. Now why this works is that we've just said that x is 0 when I'm looking at the y-intercept, which means I simply get y is equal to 0 plus c, so my y value is c. Now that's your basics of your equation, which you can tell simply by looking at it. Let's move on now to how do we plot a graph. Plotting straight lines are the easiest graphs to plot because all you need are two different points on your graph, and then you can simply join the dots with a ruler. Unfortunately, if a graph does go through the origin, which we know is the point 0, 0, you obviously then don't have 2 points to join the dots, and therefore it's a bit more difficult and you need to find a point on that graph. Let's start with an example that says f of x is equal to 2x minus 1. I know that that, in other words, means y is equal to 2x. Sorry, I think I said minus 1 plus 1. Easiest way to plot a straight line graph is not to find two random points, but to find our x-intercept and our y-intercept. We know that at our x-intercept, our y value is 0, which means I can substitute in 0 for y, which would be 2x plus 1. I can subtract 1 on both sides, and then I can divide by 2 on both sides, and I get x is equal to a half. Please make sure that if you're asked for the coordinate of the x-intercept, that you actually give it in coordinate form, which is negative a half, 0. Be sure to read the question if they want you to give a coordinate when they ask for the x-intercept. The y-intercept, we just simply have to check if this equation is in standard form, and it is. It's written as y is equal to something times x plus a constant. Therefore, it's quite simple for me to know that the y-intercept is x is 0 and y is 1. Once this is done and you find your x and y-intercept, considering they're not the origin, it's very easy for us to simply plot this straight line. We've said that the y-intercept is 0, 1, and the x-intercept is 0 for the y coordinate and negative a half on the x-axis. Please make sure that you always label all intercepts on graphs. Even if there's a 1 that denotes that this is the point where y is 1, I would encourage you to actually write the coordinate down. And with our x-intercept, it's especially important because it's halfway on the axis with nothing to say that it might be negative a half, so it's very important. We then just take a ruler and join the dots. We should always put arrows at the end of our functions, as technically they carry on forever, and we should label our function, which is why we like that f of x notation. It allows us to label our straight line very easily. Let's go on to our second example of plotting a straight line. Example 2 says we're plotting f of x, which is y, is equal to negative 4x. I would take the same approach here. I would find the x-intercept and the y-intercept. In this graph, I can immediately notice that there's plus nothing at the end, which means my y-intercept is x is 0, and my y-intercept is x is 0 and y is 0, which means that will also be the same as my x-intercept. Clearly, this graph is going straight to the origin, and therefore the two intercepts are not enough to draw this graph. Now, the important thing to remember is that this equation of y is equal to negative 4x allows you to find as many pairs of coordinates as you want. You can pick an x value, you can substitute it in, find the corresponding y value, and then you have a point on your graph, which is exactly what we have to do here. I'm going to pick an x value of 1, and I'm going to say let x be 1. You can pick any x value. I pick small values because they're easy to work out and easier to plot. If x was 1, at this point, y would have a value of negative 4. Therefore, the point 1, negative 4 is on your graph. So if I go down to plot my graph, my x and y intercepts were at 0, 0, which was going through the origin. And we've just worked out that 1, negative 4 was another point on the graph. Again, we pick up a ruler, we join the dots, we make sure we put arrows on the end, and we label this f of x. Right, let's move on to equations from graphs. I think the most important thing when being asked for equation of any function is to realize the function that you're trying to find the equation of and to immediately write down what we call the standard form. You need to know what you're trying to find in order to go and find it. So I would write down y is equal to mx plus c as soon as I realize that I'm trying to find the equation of a straight line. Quick recap, we know m is gradient. We know that there is a formula on our formula sheet which says gradient is y2 minus y1 over x2 minus x1, and we know that c is the y-intercept. So let's go to our first example. Find the equation of the following graph. Immediately I would write down it's a straight line, so y is equal to mx plus c. I always try and look if they've given me the y-intercept because that will give me immediately the value of c, and they haven't given me the y-intercept, so immediately I'd write down y is equal to mx subtract 6. Now, secondly, I need to find my gradient, which is very simple since I have a formula. So gradient is y2 minus y1 over x2 minus x1. It really doesn't matter whether I choose this point or this point as my second point or my first point. It simply matters that whatever point you choose, that you use that particular coordinate first in your equation. Considering the fact that I don't have this coordinate written down for me, I always get into the habit of writing down the coordinate of these two intercepts so that I don't make a silly mistake when I'm substituting into my formula. So I'm going to choose this point as point 1 and this point as point 2. It's completely arbitrary, which means I have a y value of negative 6 and I'm taking away a y value of 0 divided by an x value of 0 take away a x value, of minus 2. So I have my gradient is minus 6 over 0 plus 2, which is 3, which is a gradient of minus 2, which means I'm complete. Therefore, y is equal to negative 2x minus 6. Please make sure that you always look back and think, do I think I'm right? Now, I do think I'm right because I can see my gradient of my graph is slanting downwards. Therefore, I did expect a negative gradient. It does go through minus 6 on the y-axis, so I think this is probably correct. Right, let's turn our attention to the second example, which I specifically chose because it is a straight line, but we haven't given you the y-intercept. It is a straight line, so I would begin with writing down my standard form of my equation, and then looking at my graph and realizing, oh, I don't have a y-intercept, so I can't automatically tell you what the value of c is. It's not a problem though, because we do have 2 coordinates, which means we can quickly work out the gradient. So let's start there. Gradient is y2, take away y1, over x2, take away x1. Again, any of these points can be point number 2 or point number 1. I'm going to have 6 take away 2, 6 take away 2, divided by 1 take away negative 1, 1 take away negative 1, which is 6 take away 2 is 4, 1 plus 1 is 2, and I end up with a gradient of 2. Please take a moment to look at your graph. Is that possible? Yes, it is. This is a positive gradient. My graph is sloping upwards, so I'm probably right. Which means at the moment I have y is equal to 2x plus c. Now this is the most important things about graphs, which I think people forget, is that if you are given a point on a graph, that means that that point can be substituted into the equation for that graph, and that point will, we call it satisfy the equation. It will work in the equation. So I can substitute in y is 6 and x is 1, and it must work in this straight line equation. Now, why that's wonderful is that as soon as I do that, if I substitute in y is 6 or x is 1, I now have an equation with one unknown, which means I can solve for my unknown. And that's the most powerful thing to remember with equations. If you have an unknown in the equation, you can always substitute in a point on the graph. If I picked negative 1, 2 to substitute in, I would get out exactly the same value for c because they both work on this straight line. If I quickly solve this, I get c is a value of 4. Which also looks quite possible because here I have a y value of 2 and it goes up to 6. So going through the y-axis at 4 is possible. Therefore, my answer at the moment is y is equal to 2x plus 4. Now that's a brief recap of a straight line. The important thing is to practice. There's no reason for you ever to get a question wrong in a straight line because they really are the most simple of graphs. So please make sure that you practice your straight lines.